Okay guys, so in my last video I showed you how to upgrade the spindle on your 3018 CNC by making this type of a holder. Just you can mill out from this CNC machine itself using the original spindle. And I think that the solution is as good or even better compared to any other 3D printers solution out there. Today I will show you another way to do it. It will be a lot more sturdy because everything will be made out of aluminum, but it also requires more work and also tools and materials. So what you need is just this type of spindle clamp. Just come with this spindle when you buy it. Two of these bearing blocks, SC8UU. Just you will have to like trim a bit later. I will show you why and how. And this type of anti-backlash nut T8. You will have to pay attention when you buy this type of nuts for the 3018 CNC. Just the 3018 CNC machine use this less screw, just have 8mm diameter and 4mm lead. So you will have to buy the corresponding nuts for it. That will be very important. If not, it doesn't fit. And you will need also some aluminum plate. Maybe 6mm thick or less. Not too thin though, because if you want it to be sturdy, just keep it about like 5 or 6mm. One piece of aluminum angle like this. Just make sure that the side of this should be large enough to cover all the 4 holes on the linear bearing. I will show you why later. So now let me just show you quickly my design for the setup on the computer, and I will change this back to the original spindle just to make sure that you can do it even with your original setup of the 3018 CNC machine. Okay guys, so let's just take a quick look at the spindle holder setup. You will have the original spindle clamp here, just going to be attached on this plate, just going to be made out of aluminum using the M6 bolt, just come with the spindle clamp. And this aluminum plate will be attached on the linear bearing block through the hole, just using some of the M4 bolt. And here is the angle aluminum piece that I showed you earlier. Just on one side you have the hose here to attach the anti-backlash nuts using some of the M3 bolt, and on this side it will be bolted out to the linear bearing blocks. And for these nuts to fit inside the setup like this, I will need to trim off some part of the linear bearing block here. So to do this, I'm just going to use any type of saw, like Dremel tools, angle grinder, whatever you have, and whatever you feel comfortable to use. And this tool rail here is the original rail on the Z-axis, so the space here is very limited, so that's why I need to trim this off. And I won't be making the aluminum pieces on the 3018 CNC because I don't think that the original spindle will be like powerful enough and the machine is sturdy enough. So what I'm going to do is just I'm going to make some drill guide using plywood on the 3018 CNC, and then I will just attach them on the aluminum pieces, and then use the drill or drill press would be ideal to drill the holes using the corresponding like diameter drill bit. So let's just get to it. I don't think just I need to show you much on the setting up the cam because it's really easy. You only need to pre-drill all the holes like with some small bit. For me, I will use 2mm bit because the holes here need to be a 2mm. So I just going to use the same bit for all the holes here, and then I'm going to use the 3mm flat end mill to cut the pieces out from the stock. Okay, so now I just going to go to manufacture, create a setup, choose the reference point here. Stock, I'm going to put 10mm on the side and 0 on top. But I think I'm going to have to use the 6mm thick, and here the model only 5mm, so I put 1mm offset at the bottom and then click OK. And now just click on drill and then select the tool. Here I can choose any tool because on the machine I just going to use the 2mm bit. So I just click on like random bit here, 3mm flat end mill. Okay, and here I put like probably 3000 RPM so it doesn't burn the wood. And here I just put like 100 plunge rate and maybe 200 retract feet rate, and disable this. And here I just going to choose all the faces of the holes that I'm going to drill. Okay, and then this I put like 2 1.5. And here on the bottom high, I don't want to drill all the way through. I just want to drill a little bit, so it's kind of like spotting drill. And then later on I'm going to use the drill press to drill all the way through. So here I put probably offset about 2mm, so it's only like 3mm inside the stock. So that's it. And here, yeah, nothing, so click OK. So the drilling part is done. So now next step is just I need to do a 2D contour to cut this piece out. So I click on 2D contour and then select the same tool. Okay, disable this. I just reduce the plunge rate a little bit. And here I choose this contour. And I'm going to use tab. Here probably 1mm tab high. And then tab distance I want to increase to get a bit more tab, so I'm going to reduce this to like probably 15. Okay, so here I have the 2 extra tab on the side, so I feel a bit safer this way. And here I put like 2 1.5. And here I want to go like all the way like through, like cut the piece out. So I'm just going to do maybe bottom, stock bottom, and then offset will be minus 0.5. So we cut all the way through. Here I will do multi depth, 1mm step down should be fine. And here I always disable the lead in and lead out and click OK. Now everything look correct to me. So next step, just make sure just you save the path like separately, because you're going to use the 2mm drill bit for this one, and you're going to use like 3mm flat end mill for this. Next step, I'm just going to show you quickly how the machine cut these pieces. Now I have all the drill guide pieces cut out here. The next step is to trim the aluminum pieces to like shape and size. So first of all, on this angle aluminum, I just like put this piece on here and mark where I need to cut it. That is very simple for this one. Just I only need a line here to cut it. And this one I will have to kind of like cut it at the size. So I'm going to trim it here and just draw a line around it. And I will make probably like 3 pieces of this spacer. And this you don't need to be exact, just roughly like this. Okay, so when I trim all the aluminum pieces to size, I will show you how I drill the holes. Okay, so now to trim all this piece of aluminum, I just going to use my chop saw. Just make sure just you take all the safety precautions when you're doing this. Okay, so now for the pilot drilling part, the most difficult one probably the angle aluminum piece. So what I do is just I take the drill guide for the like bearing side here. I just like glue it on here using the glue gun again. So now it's really like fixed on this piece and it doesn't move when I do the drilling. So that's how I'm going to do some spot drilling on this. I don't need to drill like all the way through. I only just kind of like drill in a little bit so I have the mark, and then I'm going to take this piece out and then drill again all the way through. And after I am done with this piece, I just slide this piece in here and then glue it on here also, because I already designed all the slot here, so it just snap right in and it stay in position, and then you have the position of the hole just at exactly the place that you need it to be. So now I just going to run the drill. For this piece I use the 3mm drill bit. For the other one I use 2mm drill bit. Okay, so now I glue this piece on here. I just going to cut and take this piece out. Okay, so now I have all the hole here pre-drilled, so spotting drill. I just going to use the bit that I need at the side, so to drill all the way through. For example, this 4 hole here will be 2mm, and then this 3 hole will be like 10mm or 10.5, and those are 4mm. So I just need to take the corresponding drill bit and then drill all the way through the piece. Okay, so the next step, I'm just going to make M3 thread on the 2mm hole here. Okay, so now the hole are threaded. Let me just test if I can install the nuts on this. Okay, so I have the nuts here, and it actually doesn't really slide in here because I think this hole needs to be enlarged a little bit. Probably 10.5mm would be good. But all the small holes here are lined up perfectly, so that's the good news. So I'm just going to use my Dremel tools and enlarge this a little bit until this slides through. But as you can see, just making the hole just at the right position using the drill guide just you cut with your CNC machine is really easy. So I'm just going to finish all the other parts. The next part is just to trim off some piece of this bearing block. So what I need to do is just I trim in here about 3.5mm and leave about 3.5mm on top. So I'm just going to take the marker and kind of mark all the areas that I need to trim off, and then I just attach them on here on this block, so I can kind of have more room to handle the bearing block, and especially when I cut it with the saw, I don't cut off my finger. Okay guys, so I make the mark on the bearing here on all the side here, just a place I need to chop it off. So to do this, I prefer to use the table saw because I can adjust the blade height to the line here, and then I can just keep sliding back and forth until I chop it to this line. And I'm going to use this blade to hold the bearing so I have more space. So as I told you before, just not to chomp off my fingers. I just use some M4 bolt, 20mm length, to fix this bearing under this plate. The inner part here where I'm going to chomp it off. I don't want to use really long bolt because you can cut the bolt and it's steel, so it would be hard to cut. So that's why I put some nuts here, just kind of space it up. So you only have about 2mm just bite into the bearing thread, so it won't be cut. So as you can see that the first cut, as I said, is just cut right at the place that I need to cut. Now I only need to trim this part off, and this will be very easy. Okay, so now I cut it off here, the parts that I need to trim. So now I only need to clean it up a little bit using my Dremel tool. Okay guys, so I trimmed this piece, so it's kind of fit nicely now. And also on this plate, to hold the spindle clamp, instead of drilling the 6mm hole for the bolt to go through, I just decided I only drill a 5mm hole and make some M6 thread in this, so we can just instead of using the nut at the back, I just bolt the spindle clamp directly on this plate. Now I ran into a problem. Just I test the tolerance of this bearing block with a kind of M8 shaft, and they are really loose. You can move in almost any direction. You can feel the imprecision of the bearing block. So I try to take one out here. So you have two problems. The first problem is just the bearing slide in here very easily, and it also kind of loose. So it already have imprecision in this setup. And then another one is just when the shaft go in here, and it have it's move on the shaft. So that's the second imprecision. So The first one here to fix it is easy. Like I just going to drill like some holes here and make some like M3 or M4 thread on this. So I could just going to slide the bearing inside and use some set screw to like set them down so they wouldn't move inside anymore. So that part can be fixed. And this part, like on the shaft here, I cannot really fix it because well, it depends on what type of bearing you buy. So I try different brand, like this one and this one. Well, they look almost the same, but they come from different supplier. But the imprecision is still there. You have like, it's kind of loose on the shaft, so I don't think I can use those. So what I'm going to do, just I'm going to use the bearing just is already on the Z-axis. That one probably is going to be a bit better. Maybe it's still like not precise, but you get the same thing as the original setup just you have. The thing is just the bearing on the Z-axis right now is not 24mm length like this one. Just you can just like slide in here and lock it with the snap ring. That one is only 17mm length, so it's just two of them just a bit longer than this. So I just going to drill like two holes here and then slide these two of them in here and fix them down with the set screws. So let me just do that. Okay guys, so I just got the hole just drilled and threaded on the bearing block here. I just dismount the Z-axis and I got the original bearing here. So what I'm going to do is just, well, you have to make sure that they line up like this and push like one of the bearing inside, like to the edge of this. You might need to pound it in a little bit using the hammer or whatever. So all the way to the edge, and then the other one on the other side. So once you push it in, it's going to be like this. This side is kind of stuck out a little bit, but that's fine. So next step, just use some of the M3, well, whatever hole you thread it with. For me it's an M3, so I use some M3 set screw and I just lock it in so it doesn't slide out. Okay, so now it's really like solid. So let's just do that on both. Okay, so now the nut is installed. Next step, I just going to stack this plate, this one. You will need like two of this spacing plate. It's about 10mm, and then you stack this one and this like this, and then bolt them down to the bearing block like this. Just remember, just this side like at the bottom, this like go up here. So let's just do that quickly. So here I only have like M4 20mm length, but if you have something longer like 25 will be perfect. Okay, so at the end you should have something like this. So let me just install the nut setup. So right now I'm not going to install the spindle clamp on this yet. I'm just going to try to put everything together back into the Z-axis block. So for me, this side go up, this side down. So I should put it on like this. Yeah, the rail should slide like right in here. Shouldn't have any kind of problem getting stuck or anything. Okay, so now you have the Z-axis just installed here. Should be like sliding up and down normally, no problem here. So now next step, I just going to reinstall the stepper motor and install the spindle clamp. Okay, so now I have the stepper motor installed, this plate back on. It's really like sturdy and solid. I don't feel any type of like loose movement here. So you should be able to test, like make it move by turning the last screw with your finger here, because those stepper motors are pretty weak. So if you cannot really move it with your finger, that means it's not really smooth, and it might lock up the stepper motor might lose steps. So just test it quickly like that. So now I'm just going to install the spindle clamp here. I'm just going to use some of the M6 bolts, 60mm length. So just slide them in. I'm just going to tighten this side, just it's not opened first. This side I can just tighten it lightly, just let it loose. Okay, so now I have this ready, and let me just install it on the machine and show you if it moves smoothly or not. Okay guys, so I just installed it on the machine, and here's what it looks like. And you can see here that the motor is still working as normal. And let's move it up and down to see how it goes. Okay, so as you can see that you can still moving up and down very smoothly, even though it appears to be very heavy because it's made out of aluminum, but apparently it's not a problem. And this is probably not the easiest way to upgrade, because you will need more tools, materials, and also spend some time to work on those pieces, but it will be worth it because this is very sturdy. So it will be up to you to choose between this setup or the previous setup. If you decide to do this one, even though it's a bit more difficult, but it will be totally worth it because it's very sturdy. I hope that this video show you another good alternative to upgrade the spindle, and hopefully I will see you again in the next video.